So in this lesson, we're going to be looking at the theory behind what are called colligative properties. That is, why it is that when you add a solute to the solvent, that the boiling temperature goes up and the freezing temperature goes down. And we're going to add a third colligative property we haven't talked about yet in this class, and that is why it is that vapor pressure is reduced when a solute is added to a solvent. So let's kind of harken back to the very first unit we did in here. We talked about what the nature of science is. The nature of science is to figure out how and why the universe works as it does. Now, some people will argue that why is a discussion of, that the universe has some kind of, there's some thought process that exists in the universe, and that's not what science deals with. So they would prefer to use the term how. But I find that high school students kind of get confused when you say how, and they think that's just how to solve a problem on a piece of paper. Well, that's not the same thing. We're talking about what is it that causes this behavior that we see, okay? What is it that causes this behavior that we see? So that's the nature of what science is all about, all right? What I want to know is, in this unit, one of the things that we looked at is boiling point, freezing point, and I want to add to that something called vapor pressure. Why does adding solute to solvent cause this behavior we see? Where you add the solute to solvent, boiling point goes up and freezing point goes down. So why does adding solute to a solvent cause, okay, this kind of physical cause is what science is about, trying to figure out how or why the universe works, cause freezing point to drop, boiling point to increase, and we're going to add this. I said we haven't discussed this before, vapor pressure to drop. So I'll have to talk about what vapor pressure is here in a minute. But they're all what are called colligative properties. All of these are what are called colligative properties. These are some of, not all, some of the colligative properties. Okay? Some of those colligative properties. All right. So this is where we're going to talk about the theory now. So I know I'm not a great artist or anything like that, but here's a beaker I'm drawing, okay? Whoop, I didn't loop that back around there. The beaker. That's what we're supposed to have as a beaker. And we're going to fill it with some kind of solvent. And we're going to dissolve in that solvent some kind of solute. And remember, both the solute and the solvent are made of these structural particles, molecules or atoms or ions. But we're only going to show structural particles here for the solute for this illustration, this understanding here. So I'm just going to put a bunch of dots in here which represent the solute particles, structural particles of solute, okay? So the dots are solute particles. So we've got some kind of solvent in here. So what we're going to discuss now, and I want to ask you to help me out here, help me to grab this idea and digest it mentally. If we're going to have the freezing point drop, what happens when you freeze something? What's going on with the structural particles in a substance when it freezes? Regardless of whether it's a crystal or not, how is the one structural particle related to the next when it's frozen? How is it behaving differently than, say, a liquid or a gas?
Not moving.
Not moving relative to each other. And now they are wiggling and they are twisting, okay? But they're just stuck in place. All right, it's like you guys in the desk. You're stuck in place. All right. Now sometimes you wiggle and twist, okay, like Taylor right there is wiggling and twisting right now, all right? But he's not moving relative to Elijah, all right? He's stuck in place. That's like a solid, all right? Now liquids, on the other hand, when they are in that liquid state, what's the difference in how one structural particle relates to the next? Are they stuck together? Are they stuck in place? They're moving around. They are touching, but they're moving around. All right? So what would make it, if we're going to cause the freezing point to drop, then it must be harder to get it to freeze when we add these solute particles to the solvent. Why would that be? I have to get around them. That's the way to think about it. Okay? Every time you freeze a substance, a pure substance, there's a way that they stick together. All right? That's their way of doing it. If you put other things in there, you keep it from happening that way. Make it harder to happen. Does that make sense? Now, that's a super simplified way of thinking about it, but that works. It makes it harder for them to stick together because you put something in the way. All right? What about boiling point? Now, boiling point means we're going from a liquid state to a gaseous state, right? What will be causing the boiling point to increase when I add these solute particles to the solvent structure that will make it harder for that solvent to leave that liquid state and become a gaseous state? Well, in the way, okay, yeah. It's not quite the same in the way, but it's in the way. They get in the way. When we boil these things, we have to get these solvent particles to move fast enough. They're going to jump out of the whole liquid. Okay, they're going to leave. When boiling, solvent particles are moving so fast that they actually jump out through the surface here. Okay, they leave. All right. If I put solute particles in there, they're kind of blocked away. How about the vapor pressure? Let's talk about what the vapor pressure is. All right. Recall in the last unit when we did gases, we talked about what pressure is. What is the definition of pressure? Pressure is the application of some force to, well, let's make it a surface rather than an area, to a surface. Whenever you have vapor forming out of some liquid, that vapor starts out as a liquid, has to cross this boundary between the liquid and the gas, and that's a surface. So the particles leaving this exert a pressure as they cross that barrier or that surface. So the pressure of the particles going through that is a pressure applied to an area, or a force rather applied to an area. It creates a pressure called vapor pressure. Okay? So why would adding solute particles to the solvent lower the vapor pressure? It means that there's fewer particles going through, because the more particles we had going through, they're in the way. The solute particles are in the way. Alright, so that's the theory underlying why it is that boiling point increases, freezing point drops, and vapor pressure drops when you add solute to solvent.